As glaciers erode and degrade the landscape, making erosional degradational landforms, they are of course going to pick material up, transport that material, and deposit it. Glaciers degrade the landscape through plucking and abrasion. Plucking is the scooping and lifting effect of the glaciers, like they pick material up and transport them. Abrasion is a scraping and grinding effect of the glaciers. Then what's going to happen is that material is going to be transported and deposited. Everything deposited by a glacier we categorize as drift. However, drift is kind of sub-categorized. We can have till, which is unsorted glacial deposition. This means big stuff, little stuff, hodgepodge, willy-nilly, helter-skelter, all mixed together. The characteristic of till is that it is deposited directly by the glacial ice, because glacial ice does not sort material. It does not transport and deposit in a hierarchy. And outwash. Outwash is sorted glacial deposition, but it's deposited by glacial meltwaters. So in other words, as the glacier melts, a river is going to run away from the snout. The snout is the end of the glacier. And as that happens, all running water transports and deposits in a hierarchy, which means sorted glacial deposition. For our purposes, the main landform that I want you to be aware of is something called a moraine. Moraines are hills composed of tills. So in other words, moraines are deposited directly by the glaciers, and they form along the periphery of a glacier, which means the edges of the glacier, the sides of the glacier. And again, for our purposes, although there are multiple versions of moraines, I want you to be acutely aware of terminal moraines and lateral moraines. Terminal moraines form along the snout, which is the end of the glacier, and lateral moraines form along the sides. Terminal moraines indicate the greatest glacial advance, whereas lateral moraines indicate the former width, how wide the glacier was. If you look at this photograph here, you can see that the white arrow is pointing at the snout, the end of the glacier. By the way, if you look at those black streaks in the ice, those are either lateral moraines, depending on where they are, or medial moraines. If you look at this diagram now, you can see the blue arrows pointing at the glacier. Then you can see that the purple arrow is pointing at the current snout of that glacier, the end of the glacier. Now look at the red arrows. The red arrows are pointing at the terminal moraine. There could only be one terminal moraine on a glacier. As I said, it forms along the snout and it indicates the greatest glacial advance. You can see that behind that, in between the terminal moraine and the glacier itself, there's something that says recessional moraine. A recessional moraine indicates a period of equilibrium in a receding glacier, but I'm not going to hold you to that. You can also see ground moraine. This is the material that's dropped along the ground as the glacier is receding. But then notice in yellow, lateral moraine. Lateral moraines are formed along the sides and they indicate the width of the glacier. It kind of works like this. If you had a pile of sand spread out on a table and you took your fist and you shoved your fist through the sand, not only is sand going to pile up on the front of your hand, so on the front of your fist, that would be like the terminal moraine, but you're going to shove the sand off to the sides also. That would be like the way the lateral moraines are being formed as the glacier piles down and pours out of that glacial valley, transporting material and dumping it along the sides and the front and the edges of the glacier itself. You see that blue arrow there? It's pointing at the glacier. At one point, that glacier came all the way out, and you can see it shoved all this material here where the white arrows are at. That's the terminal moraine for this particular glacier, at least at one point, when it shoved this material out of that valley and then piled it all up along its former snout, because you can see the glacier has receded. You can see here's another terminal moraine. If you look kind of up behind, you can see the mountains. And the glacier came down out of those mountains and then shoved all this material there where you can see that bronze arrow pointing at that kind of lumpy mashed potato looking hill. That's a terminal moraine. Take a look here. It's a little more complicated. You can see in the bottom the blue arrow is pointing at a type of drift, which is till. Look at that. You can see that it's all mixed together, big stuff, little stuff, all together because it's being deposited directly by the glacial ice. Down in the bottom of that valley, you can see the bronze arrow is pointing. Barely you can tell there's a river that runs away from the snout of the glacier. That, of course, would be outwash because it's being deposited by the meltwaters, and running water always transports and deposits in a hierarchy. Then you can see off to the sides the two lateral moraines, and you can see the glacial ice, so it went right down through there and shoved all that material off to its sides. This is the same area, the same glacier, the same lateral moraines, but from a different view, and you can see clearly those lateral moraines coming down away from that glacier that's coming down out of the mountains. And if you look over here, you can see that there's a glacier up here in the mountains, and you can see that river running down out of the mountains. That river right there, of course, is going to be depositing outwash. Again, you can see lateral moraines coming down out of the mountains here. And what happened was the glacier came from up here. You can see there's a cirque here and a cirque right here. The glacier came down out of the mountains, and then along the sides it deposited these two lateral moraines, which indicated the width of the glacier when it was here some 10,000 or so years ago.